what's going on right
and said, look, the square root of 1 doesn't exist, but our square root of negative 1 doesn't exist, but if it did, it would be really handy. We could solve a lot of math problems that we can't otherwise solve. And so a gentleman by the name of Rene Descartes, who also developed the Cartesian coordinate system, the XY axis was named after him, the Descartes Cartesian. Get it? Okay. He was also a, hey, boys, he was also a French philosopher who is most known for his statements, I think, therefore I am. Okay, have you heard that before?
I think so.
What he tried to do was prove the existence of the world, and so he said, let's pretend that nothing exists. But since I think, then I must exist, and then he took it from there. Anyway, he came up with this idea of naming the square root of negative 1 with a lowercase I, and the I stands for imaginary. All right? And it turns out, after he did that, it says, today, practical applications of complex numbers abound. So there are lots and lots of uses for complex numbers. Okay, well, a complex number is complex number. Any number of the form like that, where A and B are real numbers. Okay? So if you have a number plus a number times an imaginary number, those two things get put together to be called complex numbers. Okay?
So all those are complex numbers?
A plus BI is a complex number. So for example, 3 plus 4i is a complex number.
Like a equal a complex number?
What's that?
Like it will equal a complex number?
No, that is a complex number. No, it's not. It's one number, but it's got two different parts. A is the real part, and BI is the imaginary part. Okay? So it is one number. Courtney?
Courtney, how many numbers is that?
It is one number made up of two separate parts, a real part and a imaginary part. And so obviously, for this example right here, what's the real part?
3.
The 3. And what's the imaginary part? 4i. Okay. So you can do regular, or can I go for it?
Yes, sir. Oh, wait. You're solid.
Why are you even in this class?
She doesn't think it out.
Okay, you can add and subtract complex numbers just like normal, which is one of our learning targets today, that you would be able to add and subtract complex numbers.
And multiply.
And we'll get to the multiplying in a second.
No.
And the way that you add them
Yes, it's a 7.
is you really just sort of think about combining like terms. So if you have 7 minus 3i plus 4 plus 5i,
Yeah.
yep, you're going to add the real parts together. So 7 plus 4 is 11. And you are going to add the imaginary parts together.
So you're always.
I.
Pretty sure we did this yesterday. Or last year.
Yep, we looked at these last year. And so that's how you add
We're so slow.
complex numbers.
Scared.
Okay?
I'll.
Subtracting complex numbers is the same deal.
Check. What was this? Subtracting or adding?
Well, we just did an addition one. Now we're going to do a subtraction one. And yeah, so shouldn't be any surprise here. You subtract the real parts.
Question.
2i.
Yeah.
So we don't just always leave this x as one number?
Correct. That's the answer. 11 plus 2i. So you subtract. 2 minus 8 is negative 6. So you subtract the real parts. The only possible way that you could get tripped up in this is that you're subtracting both of the numbers in here. So this is not now negative I plus 3i. It's still negative I minus 3i. So that will be
I feel like it's like y1 minus y2 and x
Negative 4i.
minus 4i.
Got it wrong. Taylor, why'd you do that?
Minus I minus another 3i.
That is not cool.
is
Wait, how does that
a total of 4i's.
Dude.
Minus I minus 3i minus 4i.
Taylor, you're so sad.
Okay?
You sit next to numbers.
So hopefully everyone in here, with the exception of Courtney, can add and subtract complex numbers now on their own. Now let's take a look at the more complicated ideas of multiplying and dividing.
Yeah, not that too. For T's. Gosh. Mr. Aldridge, is this
we just distribute?
Never yelled at anybody in this whole class ever in my life.
Well, maybe you should.
I didn't yell at Courtney. I just said,
You did actually yell at Courtney last year.
I did?
Yeah.
I get like mad and stuff.
Yeah,
yelled
you
at
actually got
Boris.
mad. Yeah.
Probably
Because you were being
Boris,
an
yeah,
idiot.
not this Boris.
Yeah,
That's true. I remember yelling at Forrest.
Yeah, you freaked out on it. That was awesome.
Last year?
Yeah.
Oh, yeah, because you always get mad at them because it was like forced people to Kenzie.
Right.
You always get mad at them because they wouldn't do anything.
And after that, they were like, I never want to take this.
What?
Called that one. Didn't pay attention, you would suck it.
Lane? Yeah, probably yelled at Lane. Okay, anyway, so multiplying. To do this, since you're multiplying a binomial times a binomial, you just need to FOIL them. Okay? So it's first times first, just like always. So 2 times 5 is 10. And then it is outside times outside is negative 2i. Inside times inside is plus 15i. And then 3i times negative I is negative 3i squared.
Wait.
Okay? So before we go on, I'm going to make sure that everybody understands what I just did. First times first, outside times outside, inside inside, and last times last.
The square is negative 1.
Okay, so did everybody get how we got those 4 terms?
Yes.
Okay, now we're going to simplify, okay? And somebody pointed out we did this last year in advanced algebra, so this shouldn't be like, you know, totally
Can we put it in like...
bizarre. First thing I'm going to do is I'm going to combine these like terms. The negative 2i and the 15i. How many i's is that? It's 13i. Okay? And then here's the trick. If we go back to the very beginning and say that square root of negative 1 is equal to I, when you take I and square it, what do you get? Negative 1. Good, because when you square it, you get rid of the square root. Okay? So this is an important thing for you to remember, know, and understand. Courtney, write this down!
I squared equals 1?
I squared equals negative 1. Okay?
Does that mean I have to figure this out?
So anytime you see an I squared, you can change it into a negative 1. Right, so then the negative 3 times the negative 1 will really work out to be a positive 3. So 10 plus 13i plus 3, which simplifies all the way down to 13 plus 13i. Okay? Oh no. Okay, you guys get that? All right, that was kind of a lot. Let's do one more of those examples to make sure. So somebody give me a complex number.
7 plus
7
2i.
plus 2i. We give you another complex number.
5 plus 4i.
5 plus 4i. Okay, and what I would like you to do right now is on your own, boil that out, multiply it out, simplify it, get it all the way down to standard form, it's called, with a real part and an imaginary part. And then we'll see if you get it.
Okay, so you got minus 8. Right? Minus 8. Oh my god. Oh, Neiman's not here. Alright. My truck.
Okay, is that what you came out with?
Yeah.
Okay.
After I realized what I was thinking.
Alright. Because that is what we are looking for.
Got a little leg.
Alright. You want me to go back? I'm sorry. I thought you had it.
Yeah.
Oh, yeah.
He's trying.
Because I squared is -1. Yeah, so I did this one very quickly. The first one I did like really slow-mo, step-by-step kind of deal. But this one right here, I know I squared is -1, so this becomes -8. 35 take away 8 is 27.
What if it's like 10i minus?
Then you would change it to plus.
Mr. Alderson read a book this weekend. The whole book? The whole book. The Perks of Being Wrong.
Oh, I wonder why you read that.
Why I read it?
Yeah.
It
That's what I thought.
was actually really sad. I mean, it
Okay, there is a special multiplication you can do with complex numbers that becomes very, very, very important in your higher level math classes like this one, which is when you multiply by what's called the complex conjugate. And the complex conjugate is, if you start with a plus bi, the conjugate is a minus bi. Okay? So you take whatever the sign is of the imaginary part, only the imaginary part, and you change it to be the opposite sign. And the reason why this is fun is because if you multiply complex conjugates together, watch, stuff cancels out. A times A is A squared. A times negative BI is negative ABI, right? A times positive BI is positive ABI. And then BI times negative BI is negative B squared I squared, right? Okay, but then like somebody said, some stuff cancels out. So this negative ABI and this positive ABI cancel. What does negative B squared I squared become? Plus B squared. And so our final answer here is just A squared plus B squared.
That equals C squared.
I squared turned into a -1.
That equals C
That
squared.
in geometry would equal, yeah, those were legs of a right triangle, and that would equal C squared. Thank you. Okay, so that is an easy way to get rid of the imaginary part of a complex number.
Wait, what about triangle?
Oh, he was talking about the Pythagorean theorem, but we don't need to get into that. So the way that you do this, the way that you use this, is when you are dividing with complex numbers. So if I'm going to take 2 divided by 3 minus I, and I want to write that in standard form, then what I need to do is I need to get rid of that fraction. And the way that I do that is I multiply both the top and the bottom by the complex conjugate. Okay? So what is the complex conjugate of 3 minus I? 3 plus I. And I have to multiply both the top and the bottom by 3 plus I because I don't want to change the value of the fraction. So I'm still multiplying by 1. Okay? Right, multiply the complex conjugate of the denominator. So what do you get when you multiply 2 times 3 plus I? Why is it -6?
Wait,
6 plus 2i.
6, sorry.
Okay, and what do I get? Let's do it the quick way. When I go 3 minus I times 3 plus I. A is 3 in this case. So a squared is 9. Plus, what's b?
Isn't it 1?
So the number in front of the I is what b is.
0.
1 or negative 1. Okay, either way it doesn't matter because negative 1 squared and 1 squared are both 1. So then that gives me 6 plus 2i over n. And then what I need to do to write that in standard form is break it apart into the real part and the imaginary part. So that would be 6 over 10 plus 2i over 10, which reduces to 3/5 plus I over 5.
I'm the dog.
Yeah, of course, because you guys sit there and visit. It's hilarious that you always go, I don't understand any of this.
No,
It really is
I
that a
do.
surprise that you sit there and have a conversation with somebody else and then totally miss what was going on? Not a surprise to me, because I've seen it every day since September 3rd.
I ace that test, man.
Okay, so when we multiply the top and bottom by the complex conjugate of the denominator, then that got the denominator down to just a real number, and then we can take this fraction and break it up into 2 pieces, the real part and the imaginary part. Did a little 8th grade reducing of my fractions. That's basically what we're learning in 8th grade math right now, and then I'm good. Okay?
Where did you get your A and B
From the definition of a complex number, A is the real part, and B is the number in front of the
from?
imaginary
So
part.
did you just automatically switch to negative by negative 1? Or
The negative I is the positive I? Yes.
Yeah, that was all good.
Yes.
You know, you get the excuse me.
Okay, so you try this one on your own.
Because I am very dyslexic.
You don't have to follow the bottom because there's a pattern that we know that's going to work out and make that easier, okay? So yeah, the top you've got a FOIL. First times first is 10. Outside times outside is 15i. And inside times inside is 2i. And then last times last is plus 3i squared, okay? So you had, Drew, the 10 and the negative 3 that that's what you're into, but you missed the 15i and 2i, okay? Now down here on the bottom, we don't have to do all that, okay? Because we know, by the way we chose what we're multiplying by, that the outside terms are giving positive 6i, the inside terms are giving negative 6i, and those will cancel. So all I need to do on the bottom is go 4 plus 9. Okay? Because when I go negative 3i times positive 3i, I get negative 9i squared, but then I squared is negative 1, which changes it back to. Okay. All right, then I'm going to simplify this. Same thing I just said, this I squared becomes a negative 1, right? So 10 take away 3 is 7. 15i plus 2i is 17i, and that's all over 13. And then the last step is done. You just have to break it down into the 2 separate parts, which will be 7 over 13
Okay, that was perfect.
plus 17i over 13. And there you go. Okay?
How does get that problem right? We don't have to do our assignment.
So that'd be a good way to go, huh?
Yeah. To show you were actually
I
paying
already
attention
know.
in class.
Yeah, I've already got it.
Can we do that?
That'd be complicated though.
How?
Well, I'd have to come around and check and see.
Just have everybody turn their notes in and then you can check.
Before I give you the answer and then I check it and then I have to grade 20 papers while you're waiting to see what you need to do.
That's
your
only-
homework.
No, all you have to do is like you look at it, see if the answer's right, then you check it, and then you get to put it in your book afterwards.
And besides, it's only one problem, not like 20.
But there's 20 of you.
Yeah, but you have, that'd be
Like what if-
Taylor would. That's 3 less assignments you'd have to grade.
Yeah, that's just like
Yeah.
I
5 minutes.
love grading assignments.
And, no.
Oh, you just like boxed it. Wasn't even a circle.
Oh, yes, it's when you box.
Yeah,
My box
it
is
was a
nice.
nice. It was a nice box.